tan x plus y. Now we know that this is equal to sin x plus y by cos x plus y, and we already know the expressions for sin x plus y and cos x plus y. Let us write them here. So sin x plus y is sin x cos y plus cos x sin y, and cos x plus y is cos x cos y minus sin x sin y. And if we now, because we need to convert these in the form of tan, because we are trying to derive the expression for tan x plus y, therefore it will make sense to divide the numerator as well as the denominator by cos x cos y. Let us do that. So we divide both numerator and denominator by cos x cos y, and we do that to get expressions in terms of tan x, tan y, etc. Now let us see what we get here. If we divide sin x cos y by cos x cos y is cancelled, and we get tan x plus cos x sin y divided by cos x cos y. So cos x is cancelled and we get tan y, and in the denominator we have cos x cos y divided by cos x cos y, where the whole thing gets cancelled and we get 1 minus sin x sin y divided by cos x cos y, which is nothing but tan x tan y. So therefore this is the expression for tan x plus y. To get the expression for tan x minus y, we simply substitute y with minus y in the expression of tan x plus y. So therefore this becomes tan x, and because tan minus y is minus tan y, this other expression is minus tan y divided by 1 plus tan x tan y, because tan minus y is minus tan y. Let us now write the expression for cos 2x. Now this we can write as cos of x plus x, and therefore we can apply the formula for cos x plus y, where we substitute y with x. Now we know that cos x plus y is cos x cos y minus sin x sin y. So therefore cos x plus x would become cos x, which is cos square x, minus sin x, which is sin squared x. And we can get this in other forms as well. For instance, if we substitute sin square x as 1 minus cos square x by Pythagoras theorem, we get 2 cos squared x minus 1. Or alternatively, if we substitute cos squared x as 1 minus sin squared x, we get this as 1 minus 2 sin squared x. Now there's something that I forgot to mention in the case of tan x plus y and tan x minus y expressions. Now because tan is the ratio of sine by cos, so therefore when we write the expression for tan x plus y, we have cos x plus y, cos x and cos y in the denominator, and therefore those cannot be 0. So therefore we write this expression with a condition that angles x, y and x plus y cannot be equal to odd integer multiple of pi by 2. And likewise, when we write the expression for tan x minus y, we say that this would hold for all values of x and y except those values of x, y and x minus y which are not equal to 2n plus 1 times pi by 2. Let us now write the expression for sine 2x. Now this can be written as sine of x plus x, and therefore we can use the expression for sine x plus y and we substitute y with x. Now sine x plus y is equal to sine x cos y plus cos x sine y. So this becomes sine x cos x plus cos x sine x, which is twice of sine x cos x. Now we can also express cos 2x and sine 2x in terms of tan x tan y. Let us try to do that. Now in case of cos 2x, we have seen that already it is equal to cos squared x minus sine squared x, and if we divide and multiply it by cos squared x, we'll get in the numerator 1 minus tan squared x, that is by dividing cos squared x minus sine squared x by cos squared x, and the whole thing multiplied by cos squared x, which is same as saying that we divide this whole thing by 1 by cos squared x, which is sec squared x, and we know that sec squared x is nothing but 1 plus tan squared x. So we can write this as 1 minus tan squared x divided by 1 plus tan squared x. And likewise here sine 2x we know is 2 sine x cos x, and we divide and multiply this by cos x, so we get 2 tan x, which we obtain from sin x by cos x, multiplied by cos x into cos x, which is cos squared x, and we know that cos squared x is can be written as 1 by sec squared x, and sec squared x is 1 plus tan squared x. So therefore sin 2x is 2 tan x by 1 plus tan squared x. Now we can write tan 2x. Now this is nothing but sin 2x by cos 2x. So we simply substitute the expressions for sin 2x and cos 2x, which we had derived in terms of tan x. If we do that, we see that this comes to 2 tan x, which is the numerator of sin 2x expression, and the denominator here would become 1 minus tan squared x, and the denominator of the two terms cos 2x and sin 2x expressed in terms of tan x would get cancelled out. Now let us move to the next page and derive